You literally just plug it in. Don't change anything about it, just plug it in. These things are being added together, so we can, make sure that they're still being added. Big old plus sign right there in the middle. What formula we have? G. So what is the G formula?
2x plus 1.
2x plus 1, right? So again, we see the G formula right here. It's in blue, so I can do 2x plus 1. You just throw them in there, and let's see some magic happen, okay? This is the setup that we do. Right, this is the setup that we do. You plug in your values, or you plug in your formulas, I'm sorry. So then that way you can set something up, okay? Before we do anything else, before we actually add these two together, questions, concerns about how these two things came about. Because I want to make sure this makes sense before we go any further. Is good?
Yeah.
Okay. If not, let me know. Let Mrs. D know. We're here to help you. In order to actually add these together, the thought that I need you guys to have CLT, combine like terms, just like we talked about that first, second week of school. Combine like terms. Let's see what sort of things we can squish together by addition. All right? First things first, x squared. Do I have any like terms to go with x squared? No. So just leave it alone, right? You have nothing, don't do anything. Just leave it. Drop it like it's hot. All right. Next up, I have a negative 4. Why the plus 1? It's a regular number, right? So, negative 4 plus 1, exactly. I'm going to throw that on the end, because normally regular numbers, they go on the end of our thing. We'll take a look. And then last but not least, what's the only other piece that we have in the setup? Plus 2x. Does he have any partners? No. So then again, just leave him alone. He's going to go here to put it into standard form. So lo and behold, what we have is x squared plus 2x minus 3. Are there any other like terms that we can combine? No. Some people will try and combine these, but be careful, they're different. This is x to the second power, that's just a regular x. So this right here, ladies and gentlemen, this would be our final simplification. It's a brand new formula. So the way that we'd write it up to make it nice and pretty, we'd have to use the official function notation. We added the two formulas together, and we did not plug any number in. We just left it x. So this right here, I'd try and fit it if you can. This right here would be your final simplification. F plus g of x equals x squared plus 2x minus 3. Okay? So that's one whole problem from start to finish. All right? All right. Let's try subtraction. I don't know, sir. All right. Let's try subtraction. We're going to do the same exact thing. We're going to set it up very, very similarly. Let me do this. You guys still need this? Anybody still need? Okay. Let me clean this up. If you do, we can always go back. Let me clean this up. All right. Let's do the subtraction one. It says f minus g of x. Guess what? We're going to do the same exact thing. I'm going to do f of x minus, big fat minus sign, the g of x. Okay? Gotta be subtraction between our two formulas. It has to be, because that's what it's asking. And so what we're going to do is we're going to take the two same exact formulas and throw them into this the same way. But here's what I would recommend. Make sure that you guys and gals are using a parentheses or something. So let's take a peek. Thing, f of x is x to the second power minus 4. For subtraction, I'm going to say use parentheses. It's going to help you. You'll see why, what I mean in a second. So I'm going to put this in parentheses. Okay. We are then subtracting away, big fat subtraction sign, we are then subtracting away the g of x formula. So again, use the same g of x formula, 2x plus 1. So again, parentheses, 2x plus 1. Okay? So you can see this one is slightly different for subtraction. We're going to clean it up, but it's still all of the f formula, all of the g formula, and then you have them kind of there together. Okay? Take a look. Make sure your setup matches. Make sure your partner's setup even matches. Help your partner out. Make sure they got the parentheses happening. All right. Nice. Now, it looks like some people are already moving on to the next step. That's kind of fancy. But let's kind of hit this together. We have to somehow get rid of these parentheses that we put in because of this subtraction problem. What do you guys think we're going to have to do with this negative? Distribute, right? If we look back at the little box, right? If we look back at the little box for multiple, for this, we wrote that you might need the distributive property for multiplication. You might need it even here for this. So we are going to distribute the negative. I would actually write out the words because you might not recognize what the heck we're doing. So this negative, if it helps, think of it like -1, and we can distribute that in. -1 times that and times that. We're going to do it to both. Okay, we're going to do it to both. I haven't messed with my f of x formula. Just leave it alone. It's still x to the second power minus 4. But now, because we were subtracting this one, that's what changes. What's going to happen to my 2x, ladies and gentlemen? Becomes negative. What's going to happen to my positive 1? What does it matter? It's going to turn into -1, exactly. And now that we've got this, these 4 pieces, we can now take a moment and combine like terms. So, with your shoulder partners, real quick, take 30 seconds, combine the pieces that can be combined, and be careful with your positive, negative signs. I'm going to pick a stick here. So take 30 seconds, dare to compare, check with each other. We are at the bottom. We're at the bottom. We're going to get to those other pieces in a second. 20 seconds. 30. Maybe. Check with your neighbor, but it looks okay. Just be careful with your positive, negative signs. All right. Let's see. Juliana, why don't you pick somebody for us pretty please? So I need to know, what are you combining? What did you get? Who we got? Oh, hey, you picked yourself. Beautiful times. All right, Juliana, what did you combine in order to get something? What did you do, ma'am?
Okay, so
Super excited. Come on.
for B,
Yeah, for these guys. What did you combine? What's your neighbor get? All right, give you like a couple seconds. All right. So we have x squared minus 4. We distributed it. It's all kind of there. Think about it. I think I got it. Yeah? Somewhere in there? Okay. Making sure. Checking. All right, she's helping her out. Let's kind of check and see while they're seeing. Let's see what we got in the interest of time. Dylan, what did you combine, good sir?
-4 and -1.
All right.
-5.
That gave you -5 for sure. Did you guys do anything with the x's at all? No. All right. So then, Juliana and Jake, the class helped us out. They gave us the 4 and the 1. But what did you guys do with your x's or anything else that you got going on? Still working. Oh man. All right. We'll leave you be. All right. Got the thing. Did you guys and gals? Did you guys do anything with the x squareds or even the -2x?
Yeah.
No, just bring them down. Right? It doesn't have a partner. It doesn't have a partner. And so, lo and behold, that should be your final simplification. Okay? And again, use the proper notation. f minus g of x, that's all equal to this beautiful new formula. That's going to be what we've got going on there. So addition, subtraction is kind of ready to go. All right. All right, let's. Anybody still need this? Let me know if it's still right. Okay. Phase 3. There it is. Phase 3. Let's get this right. All right. So we've done addition. We've done subtraction. Following right along, the third one that you guys and gals are going to have to make sure that you know is multiplication. Multiplication. Oh my gosh. So, just like it says before, just like we've done with f times g of x, we're going to do f of x times g of x. Again, you can color code this to your own advantage, but we are literally just going to multiply them. And again, it says to use parentheses to kind of help us out. We're going to have to use the distributive property. Let's see how we set this up. Right? Same sort of deal. I take all of my f formula, x squared minus 4, and we are going to multiply this, big fat multiplication dot in the middle, if you want. We're going to multiply this by g of x. Oh my gosh. We got 2x plus 1. Big fat multiplication. Yeah, that's our setup. Make sure, double check that your partner's got the same exact setup as you. We're about to get fancy. About to get fancy with multiplication. Let's see, clean all this up. Alright, now, for a problem like this, you've got parentheses and you've got other parentheses. Like we talked about earlier today, you would have to use the distributive property, right? However, normally in the distributive property, you just have like a number and stuff, and you just kind of toss it into both, right? That's normally how that would work. Here, you've got two things at a time. You've got two things at a time. And so because of that, we have to do it a little bit fancier. You guys might remember the FOIL method, maybe. Some of your teachers might have taught you guys the box method. Let me kind of remind you. You don't have to write this down unless you absolutely need to. I might recommend it. So this is a generic thing. You can toss this anywhere if you need it. So some of your teachers might have taught you FOIL way back when. You multiply the first two numbers, A times C. You multiply the outside numbers, A times D. You multiply the inside numbers, B and C. And then you multiply the last two numbers, B and D. You may have seen that FOIL. Some teachers call it the claw because it looks like a crab claw. Some teachers call it the rainbow, whatever it might be. You might have learned it that way. No big deal. Hopefully you remember. Some teachers, they may have taught you the box or the Punnett square. You guys might remember this from science, biology. A times C, C times B, A times D, and then B times D. It gives you all the same four pieces if you use the box. So, you may remember that, you may not. You may have learned it, you may not. Let me kind of show you how it works. Okay? Do either of those look familiar to you guys, the FOIL or the box? Anybody? A couple people? Try it out, try to remember, see what you got. Let's kind of see it. I'm going to do the FOIL method just because that's what I like, that's what I taught, that's what I teach. So let's do this, right? First, I got x squared times 2x. If I do that to that, it's going to be 2x to the third really quick because I have three different x's. Right? I have a 2 in the front as my coefficient. X squared times x gives me x to the third power. Pink, and I'll do one. All right. outside numbers, the ones you gotta really reach for. So that's x squared times 1. Okay, x squared times 1. Well, x squared times 1, guess what? That's just 1x squared. You can put the 1 if you want. You don't need to, but you can. Pink. We then multiply the inside numbers for the FOIL. So the inside numbers, the ones really close to each other. We've got -4 and positive 2x. If I multiply those together, what do you think you get? -8x, exactly, -8x. Nothing too crazy. And then you finish it up with your last few numbers. Multiply -4 times 1. Multiplying, careful. What do you think you'd get that out of time? Sure. -4, -4, yes indeed. That's all it is, -4.